Hey guys, welcome back to another session on my channel. We are gonna keep going with challenges related to Python in order to prepare coding interviews on educative.io. So let me configure the setup a bit better. Okay. So let's go. We were going for the heaps part. So find k smallest element in a list. This is the challenge of today. Let's see. So given a list and a number k, write a function that returns the first k smallest element using a heap. Oh well, this is pretty easy. Smallest element using a heap. So the idea here, okay, what we can do here, we can go through all the elements and keep track of those. Like we could go, we take max, we have a list and we check, for example, okay, this element, we fill it with 3 numbers, which is the size of k, and we check, okay, we go to the next and we check, okay, if this number is less of one in the list, we replace it, and we go in this way. But it could be that, for example, for the number 1, okay, we find 9, we replace it. For the number -2, we find 1, but it's not the minimum, so in that case we should go for the 4. So we have to keep track of the order of the k element we are currently storing. We could do this with a heap actually. So let's go and implement this using a heap. So the idea is that we will fill the heap with k elements, heap. After we will pop out the first element we left of the elements we left in the list. If this element is less than, okay, we could keep track using a maximum heap, and we check if the number we are getting from the elements which are in the list is less than the maximum, we get out the maximum, which is higher than the current number we are checking, and we put it in. And after, the heap will keep the sorting of the maximum of the remaining element with the new element we added, which was less than the maximum we removed, and at that point we go with the next one. So in this way, at the end, in the heap, we will have the 3 smallest number in the array. So let's go implement this. In order to do it, I will use the Python standard library. So we save, we go for Python challenges, we go for k smallest elements.py. So we define the main function, okay, we go for main. In the main, we just define a list, which can be the list of the example, for example this one. and we take trace the k element we want to extract, and we find smallest k elements, and we get it out. No, we do it. So sorry if I'm naked and like I don't have the t-shirt, but it's pretty hot here. So LST, so result, actually we can just print out the result this way. We take the smallest here and we define the function. So def blah blah blah. Here we have k and here LST. So in the head of the file we are gonna import from heap_q import star, and now because this is the standard way to use heap in Python, so we have heap we have different methods: heap pop, we have heap push, and and these elements they take usually this function they take in input the list, a standard list. We could call the result our list. So we go first of all so let's assume we are going to use this method to modify the result list in order, which will be our heap. So we will have, in a first step, we have to fill the heap with the k elements. So we just go cycle through the first k elements of LST and add them to the heap. Okay. Once we have done this, we cycle through all the left element in the list, and we decide if we add them or not to the list. By default, a heap in Python is a min heap, so on top of the heap you will have only the element, the smallest element. But we have to remember that we can create a max heap just if we change the sign of the integer we put it in. So if we change the sign, for example, we put instead of putting 9 we put -9, instead of 4 we put -4, etc., we will get a max heap. But we have, when we pop out the elements, to convert again the sign from minus, so we have to multiply per minus by minus. So first of all, we will cycle through the first k element of the list and add them to the heap. We will cycle through all the left element in the list, and we will decide if we can add them or not. How we decide this? Easy. So we check if current element we are analyzing is less than the head of heap, then we pop the head from the heap and we push the current element. Otherwise, we keep going. And that's it. So let's go implement this. So first of all, we cycle we do for e in range of k. And we do heap push result and the LST e element, okay? So, and later we go for e in range between k and lambda LST. Okay, but first of all we have to convert because it's a max heap. So okay, we push it and we pop out. So we do if LST in position 0, which is the head, is greater than LST in position E, result in position 0, which is the head of our heap, is greater than LST. So it means that we need to replace it. So we go for heap, but this should be changed because it's a max heap. So result of the head of the heap changes its sign, so we can compare it with the element in the list. So we do heap pop from result, and we do heap push of result and the element LS in position E, change by sign. And after when we print this, actually, you know what we do? We do something like this. We do for return, but we do minus a number for num in result. Okay, because we want to change them, because we want to change the sign again, because from what we said that we are using a max heap, which is the way to do it in Python. So let's try to execute the code. Yes, so we have 4, 1, minus 2, which is correct. Let's try to do something different. Let's try to add and change k. For example, we add minus 100 and we do 4. So same result plus or minus 100. Yeah, great. So seems it works. As you can see, these are not ordered, no? Like before were ordered, but was a casualty. In general, it shouldn't be. Like, it can be like this. It can be like this easily. Because when you store things in the heap, it doesn't mean that they will be stored in order. So, but the input was asking for something different. So it was asking just for the smallest elements, and not an ordered list. So that's it. That's how I would complete this challenge. So it was pretty fast. So let's go. Find k largest element. So instead, in order to find the k largest element, I think it's the same idea, but we have to use an in heap. So we will store the elements in a mini heap. This will, what it means? It means that actually the code will be almost the same. I can remove the comments. So the code will be almost the same, but we are going to use the max heap. The max heap, what we'll do? We'll do the dirty job of keeping track of the max element we found so far. What is gonna... No, sorry, I'm gonna use the min heap in order to do that. Because when we will do the comparison of result in position 0, and if this result is gonna be smaller than the current element, in that case we have to do the replacement. So actually what we are gonna do, I can implement it even here, so we can use the same test setting. So let's go here and do biggest k elements, no? Let's do the biggest, like this. So we have result, blah blah blah, but here instead of using the minus sign, we leave it like that. And here instead of using this, we just leave it like that. So, and here when we store it, we leave it like that. And we just return results without converting it again. So in this way we will find the biggest elements, because here we will do the comparison between the head, which is the biggest element, and sorry, the smallest element. And if we find an element which is bigger than the smallest element of the bigger element set, it means we found a replacement for the head, and so we replace it. So that's it. Let's try to run it. So we will do something like this: biggest, and let's see what happened. Let's see. So 974 so we have minus. Maybe I left a minus somewhere. No. Okay, the first two are okay, we know it. The other one, I don't understand why we have a -2. So, okay, because if we, okay, I have to change this sign, because if the result of the head is bigger, no, is smaller, so if the head is smaller of the current element, we do that, okay? Let's try again. Sorry, you are not seeing when I execute things, sorry guys. So this is how I execute things using PowerShell, standard way in Windows to run script. I always try to use the operative system console, not because I'm passionate or I don't want to use the IDE, but because I think you should be able to code everywhere, even on Notepad. So if you manage to write your code with whatever is the editor you want, but honestly I always try to execute the things with the tools the operating system gives me. So in this way I don't need to depend on anything else. I don't need to have that specific distro, that specific installation. I just want to be able to use everything that just the OS provides you, give you the freedom of avoiding any of depending from any vendor, from any whatever tool you are using. So this is why I'm doing this. Anyway, so now we execute it again, and as you can see now it works like it should. So 697, 5679, which were the biggest element in the list here. So that's it. That's how we completed this as well. So we go back to the page and we clear it. So we have sliding window median, hard, maximal capital, hard, and equals. Let's do it later. Okay, the thing, okay. Maybe I should start discussing even the complexity, but whatever. So sliding window median R. Given an array of numbers and number key, find the median of all the case size a subarray or window or the given array. So input names. If key 2, given an array of numbers and a number k, find the median of all the case size subarrays or windows of the array. Find the median of all the case size subarrays or windows of the array. So if you have 1, 2, you have 1.5, which is the median. Let's go Windows size 2. You have 2, 1 minus 1, which is 0.5. Yeah, I don't understand why I shouldn't do 1 plus 2 divided by 2, 1.5. 2 plus minus 1 is 1 divided by 2, 0.5. Minus 1, 3, plus 3 is 2. 2 divided by 2 is 1. 3 plus 5 is 8, divided by 2 is 4. So I don't understand why you don't do it, why you need an heap in this case. So 1 plus 2 plus minus 1 is 3, minus 1, 2. 2 divided in this case you cannot do something like that. If you have 1 is 2. 2 divided by 3, so it's more like I have minus 1, I have 1, I have 2. which is the median. Okay, I got it. So what is the median between the highest and the lowest number we have in the window? So if I have -1, I have 2. I have to divide, like I have to take these numbers, sum them. I don't know, still I don't got it. So 2 minus 1 gives you 1. So, for example, here 2 minus 1, 3 is 2, the median. Why? The median here should be -1. Well, I don't understand this exercise. Whatever, we skip it. I don't understand. I know it's the middle number, but it doesn't make any sense here because, for example, for the Windows 1, 2, it gives the median 1.5, which is 1 plus 2 divided by 2. But here what is 1 plus 2, 3, minus 1, 2. 2 divided by 3, oh, okay, 2 divided by 1, 2, it's 1. 2 minus 1, 3. 2 minus 1, 3 is 1. 1 plus 3 is 4. 4 divided by 2 is 2. Minus 1, 3 is 2. 2 plus 5, here we have the view. So it's 2 to 7. 7, it should be 3.5, the median here. No, instead here it's like here it selects the number. Here it does the division. Maybe because if it's maybe it's because if it's a pair, if it's even, it does the division between the two. But you, well, fuck that. Okay, let's go. These are boring. Building hash tables from scratch, solution sublist with a sum of 0. Guys. Building an hash table from scratch, add the remove and search in hash table implementation. A list as a subset of another list. Well, you know what, I want to do something different because I want to prepare for other things. So let's go back to module home. Let's go to another course I know, which I did it, and let's try to complete some challenges there. Wait. Let me go to lead code. I wanna search for Facebook interview question. Sign in. I should have an account. Let's see. No, nothing. Maybe with GitHub. I think I remember I used GitHub. For this type of sites, I use GitHub always. Follow me on GitHub if you want, Ricky Rants. They sent me the verification code to Gmail. I don't see any GitHub message. Manager. let's see in the spam. Yeah, here. Report is not a spam. Okay. Unread. GitHub. Yeah. Blah blah blah. Go. Personal authorize OJ lead code. Maybe yeah. Navigation. Let's do it. This is called OpenID. The technology behind this redirecting. Anyway, here we go. Blah 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 blah. So let's go to interview, online interviews, assessment, explore. I remember there was a section related, for example, to all the problems they give you at that specific company. So I'm looking for that. Lead code explore, August lead code challenge. There is a lead code challenge, and tomorrow is the 1st of August. Let's go. Let's try to do this. Week 1. You must complain with the channel. Valid submission. Later invalid submission. Only valid submission. Check how they discuss post. Week 1. What is gonna be? Problems appear at midnight Pacific time. You will have 1 day to correctly solve each problem for 10 Litecoins. After that you can still solve it, however you won't get any Litecoins. Fuck you. A new problem will appear each day. Remember the following. The first problem for week 1 will appear on Sunday, August 1, so tonight at 12 a.m. Pacific time. You have 24 hours to submit a correct solution for it. Completing all 31 problems on the day they appear will give you the entire entering the lucky prize draw. Remember, you must answer all 31 questions on time to be in to win. If you answer the pre-question you must be all submission to the August challenge must be made in this explore card to be counted. Good luck. The lead code team wishes your interview preparation. Okay, I will maybe do it for this channel. So, but let's explore interview. Let's go. Dude, it's so slow. Why? Here, Facebook. Bam, locked, of course. Let me see. Go to subscribe. Okay, let's see. Should I pay or should I go? Let's see. Let's go. I don't want to pay now. Let's go. Grokking, coding. Let's see coding. Grokking. I remember it was grokking. Come on. Grokking saved. Let's say algorithm. No, I wanna explore. Algolia. What is this Algolia? Oh, this one. Let's go for a separate sort, in place reverse of a linked list, 3 breadth first, 3 depth, 2 heaps, subset. Go for subset, which I remember was one of my was killer for me because I couldn't really understand the subset. This morning I studied a bit of permutation, so maybe I can get something here. Giving a set with distinct elements, find all of its distinct subset. Okay, the idea here is that you start from an empty, you go with the first element, and you add everything to, and you add also the solution to what you are adding. So you go, take empty, you have 1, you add the element 1 after, and you add it to the result. You go for the element 3, you take the previous list, you add 3, which is empty, okay, and so you copy and 1 3, okay. This is pretty easy. So let's do it. We can do it. We have 5 minutes. I can manage to do it. I mean, I'm not a pussy. So let's do it. So this is find subset. So let's save it as find subset. So the idea with find subset, what is, so now I would go with you guys and do mainly permutation and subset, which I think I'm not pretty strong on this, and later maybe I will do, you know what, if we did it, I would like to do something more like knapsack problems, or maybe which I think are pretty tough, and maybe and dynamic programming, which they should go together, no? Top K elements, for example, and this is this is heap again, top K elements, pattern K we merge K sorted list. Let's see, knapsack. Here we have topological sort. Okay, Michel, we can do topological sort. Okay, sorted list. Wow. You did so slow this side. Okay, anyway, can keep going with our subset. Let's stay focused. So the idea with the subset, the idea is that we will start from this type of so we take for each num in nums all the subset produced so far, and we start with empty subset, and we add an element, and we add the current element to each subset generated so far. Remember to copy the element and not modify it, because of course we have to keep track of all the possible combination. So we go for n in nums, and for s in subsets. So for each subset we take LST of s, current subset, and we go current subset dot append n. this is the list. So in this way we clone it and we append it, and at the end here we just do subset dot append current s, but instead of cycle it with a for each, in this way it's better to use something like this. So for j in range between 0 and length of subset, because if we go for the for each, we get a reference to the object, and this is not what we want. So also, since the subset will change in size while we are cycling, that could deal to some issues. So s in position j will be copied. Sorry, subset in position j will be copied. And we return subset again. Let's see if it works. So Python k smallest element max equals challenge alien there, find subset. Bam, 1313 blah 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 blah. So yeah, that works. So this is over. Let me check here. So we have merge k sorted list. Well, this is you need to deal with multiple pointers, and here top k numbers given a sorted array of number, find the k largest number in it. This is again if we did it before. So what is this algorithm? The search is a search solution that offers a function which allows the user to develop a fast search discovery experience that delight and power. Like a sort of elastic search. So this is over. We did it. That's it. So the next one, we will not have time today to do it, but it will be with duplicates, but it should be easy. Like if we order the element, we just keep the elements which have already 3. Blah, blah, blah. So if you have it, you skip it. Well, the first thing we could do, we check if we have duplicates to avoid the generation if that number is already present. Yes, so you just created, okay. So you added 3 only in the subset the step before. So if you have 1, 5, 3, okay, yeah, 1, so 1. After you have 5, so you have 5 and 1, 5. After you have 3, so 3 you add it to everything, blah blah blah, and you arrive at this point. No? So, but once you add the latest 3, instead of adding it to everything, you just need to add it to the subset you created in the previous set. And this you should do it for all of possible duplicates. So that's the solution actually. Oh Claudio, sto per uscire, voi come siete messi? Hey guys, so the live's finished for today. Sorry, it was pretty rough this one, but I wanted to do something today because tomorrow I don't know if I will manage. Maybe tomorrow I will do another hour. I don't know. Related to coding. Maybe I will I will pay for the lead code premium for the Facebook. And let's see again. I couldn't screen from lead code. The word is one side interviews. I don't know, guys. Do you believe about this? I don't. This type of advertising the companies do on their own page, on their own website. I don't know. Anyway, maybe I will start the coding challenge of lead code. I don't know. Let's see. We'll see. Anyways, keep following me, and please leave a comment if you liked, leave a thumbs up if you liked, and I hope to see you all tomorrow.